Welcome to our exploration of solubility rules, a fundamental concept in chemistry. Have you ever wondered why some substances dissolve in water while others don't? Today, we'll uncover the principles that govern this fascinating behavior. Solubility rules are like a map, guiding us to predict whether an ionic compound will dissolve in water. Let's start with the basics. Soluble compounds. Generally, compounds containing group 1A metals, such as lithium, sodium, and potassium, are soluble in water. Similarly, ammonium ions or NH4 also form soluble compounds. Next, let's talk about nitrates. Nitrate compounds, with their NO3 ion, are almost universally soluble in water, making them an important class of chemicals in various reactions. Moving on to chlorides, bromides, and iodides, these are typically soluble too, except when paired with silver, mercury, or lead ions. Sulfates follow a similar pattern. They are usually soluble. However, when combined with calcium, strontium, barium, or lead ions, they become insoluble, forming precipitates in aqueous solutions. On the other hand, we have compounds that tend to be insoluble. Carbonates and phosphates mostly fall into this category, with exceptions for those bonded to group 1A metals or ammonium. Hydroxides are another group that's largely insoluble, except for those of group 1A metals and barium. Sulfides, too, are generally insoluble unless paired with group 1A or group 2A metals. It's important to remember that these rules are guidelines rather than absolute laws. Factors such as temperature and the presence of other dissolved substances can influence solubility. Understanding solubility rules not only helps us predict the outcomes of chemical reactions, but also has practical applications. For instance, in water treatment processes, knowing which compounds will precipitate out of solution is crucial for removing impurities effectively. By mastering solubility rules, you're unlocking a key tool in the chemist's toolkit, enabling you to predict and understand reactions in both academic and practical settings. Thank you for joining us on this journey through the world of solubility rules. Keep exploring and stay curious.